Hello everyone, welcome back to this class of the SolidWorks course, and today we will be continuing what we started from our first class. So in our first three classes, we saw and we got an introduction to SolidWorks, and we saw how we can use various different commands and features in SolidWorks that allow us to go from a 2D sketch or a 2D engineering drawing or technical drawing so that we can create our own 3D model to for any purposes. For example, to have a better idea of what the part is drawn is, or for example, if we want to 3D print this part. And during the last three classes, we saw a lot of the different commands like extruded boss base, revolve, sweeps, and lofts. But today we'll do the opposite. We'll be trying to go from the 3D parts that we have. For example, if we designed a part for some function, and then we will see how we can create our 2D drawings similar to this from our 3D part. Let's say, for example, we have some application. We created our 3D part model in SolidWorks, and we want to create this part. In order to do that, we need to somehow explain all the different features of our part so that the people who are responsible on creating or manufacturing this part will be able to do that with the features and all the dimensions that we would like to have. And so to do that, we will be going through the same three parts that we did in our first three classes, but this time we will start with the 3D model already done as we did in our first three classes, and we'll be trying to redo the 2D sketches. And so to do that, it's simple. We start with our part open as we can see here. And after saving our part, we can go to the file. And from here, we can go to make drawing from part. And so this will open a different part of SolidWorks where it will allow us to create drawings. Because as we see, for example, if we create a new, what we will have is a part and an assembly and a drawing options. In the first three classes, we saw the part where we create our parts. Today, we'll see how we will create drawings. And later in the course, we'll see how we can create assemblies where we use different parts to create an assembly of the parts. So from here, we can again go to File, Make Drawing from Part. And this came to me just because like I already created this drawing as we can see here. But for you, you should not have this option. So for me, I can just click No. And this is what you will get once you choose the Make Drawing from Part. And what this gives is that it gives a standard template for creating the drawings. A lot of those would have like very how can I say, like extra options in the title block that we will not be using. However, in one of the next classes, we'll see how we can create our own template. But for now, we can choose any one of those. For example, here we can go with A4 ANSI landscape. And if you change, you can see the preview of the different templates. So again, we can go to with A4 ANSI landscape, and we can click OK. And what this does is that it opens us our sheet that will be creating our drawing on, and we can see on the right the different views of our part that we used that we would like to create our drawings for. So we can see here the different orthogonal views: top, front, left, right, back, and bottom. And also we can see other views: isometric, dimetric, and trimetric. And we can see also the current view that is what we have in this. So if we change the view from here, and if we come to this drawing, and if we from here refresh this, we can see that our current view changes. For example, if you would like to give some specific angle for your part, that is not one of those standard views. So to do that, we can simply see here that we have our front view in the middle, then we have our top view, and here we have our right view. So we can simply go to, for example, the front view, left click and drag so that we can bring it to our sheet. By releasing, we can then drag our mouse. After releasing the left mouse button, we can see that SolidWorks automatically creates the different views. So this is our front view. If we drag up, we can see our top view. Left click, we put our left top view. Then we can now drag to the right so that we can put our right view. And from here, we can simply left click. And with this, we have our right view. And since we have here our three main views, we can simply click OK. And with this, we have our three views. If, for example, you would like to add later different views, you can easily go to this right side of the SolidWorks window and choose this palette, View Palette. And from here, you can see again the different views. For example, if you would like to add an isometric view. So first things first, what we can do is that, for example, if we would like to have our isometric view to be similar to what we are using in terms of style when we are creating our part, we could simply, like, when we choose any of those different views, we will have here different options. So here the orientation, here we can see that it's isometric. And here we can see the different display styles as we saw in SolidWorks when we were creating our 3D parts. We have here the wireframe where all the lines are visible. Here, the hidden lines or the lines or edges that are behind some of the parts, they are shown as dashed lines. This is the normal edges that are visible. And here we can see the solid with like edges. And here we can see without the edges. So this is, for example, if you would like to have a better visualization of our part, for example, in the drawings, we could have this. And from here, we could also set the scale where we use the sheet scale or a custom scale, for example, for only this view. So for example, you could have it half the size. And from here, we could simply move it so that we can have it as a reference. And the others are for now not so much used, and so there's no need to, like, most of the time they will be left default and no one uses them that much. And we can see here that the same thing applies for all the other views, the same options here. So if you would like to recreate this, we could simply create this dashed lines, which are simply controlled from the display style. And as you can see, when I change the style of this front view, we can see that the style of all the other views, the top and the right, changes as well. This is because when we created our front view and those views, what we did is that we dragged one of the views, and from there we created the other views by dragging and then clicking. And so what this does is that this main view that we put at the beginning is our parent view or main view, and those will always try to follow what the main one or parent view has its style and options. So even, for example, this one, the same thing will apply. But if, for example, we have this, and if we change the style of this one, it will change only this one. And from here, we could, for example, click and press delete. Yes, to delete it. But if we do the same thing to the parent view, what will happen is that it will delete it, and one of the other views will become like the parent view, or if there are not the views are not related, what will happen is that every view will be independent of the others. So we could delete this one as well. And from here we have our different views similar to this. So after we have here our views, we could simply put our dimensions. And for putting or giving the dimensions in 2D drawings, it is similar to what we do when we are creating our part, when we are creating our sketches to create our part. So we could simply go to annotation, and as we can see here, different tabs are now available for us in this mode. We have the drawing, the annotation, where we have our smart dimension. So we could dimension our part similar to what we did when we were creating our sketches. For example, we could choose this bottom edge, left click, so that we can have our dimension. But as you can see here, the values are different. The reason is that, as you can see here, our unit is millimeters, but here we can see that the units are inches. So we could simply change the units to inches, and we can see that we have our dimension. And we could do the same thing, for example, for this dimension, and this will create our other dimension. And as we can see here, we have all the dimensions that are visible in this 2D, in this front view, in this sketch. And if you would, and for this, we could also see that the dimensions might be a bit different, or in terms of the style and how the arrows are created. This is dependent on like the different standards used. So later in the next class, we will see the different standards. But if, for example, we go to the options in here, we can see here that we have different drafting standards, and every standard will have some different display styles for the different features in the drawing. And so from here, we could simply do the same thing and add the different dimensions. For example, this angle in here as 30 degrees, and so on. And so when we are creating our 2D drawings, it's important that we define all the different dimensions. And to do that, SolidWorks also could help us in doing that by noting that here it's saying now underdefined, which means that there are some dimensions that are still not explained, and so we still have some work to do. Another thing is that we can see here that we have different lines that we call center lines, and in the top view, which are simply lines that help us to know if, for example, we have features such as like cylinders or holes. So we can see here our center line, which we can get from the same annotations tab. We can see here, if we follow, we can see those balloons we will see when we are creating our assemblies. But for here, we can see the center line or center mark. So in the orthogonal or perpendicular view to a circle or a hole, we can create our center mark. If, for example, we delete this one, if, for example, SolidWorks didn't create it automatically, we can simply add it by choosing the center mark option and selecting the circle. And the importance of this is that it allows us to give the dimensions to the hole or circle from other edges, since most of the time what's important when, for example, manufacturing a part is where is the center of the hole. So we could simply click on this center mark and then give its dimension by selecting the smart dimension. So center mark, one of the edges, for example, this one, and we have here our first dimension for the hole. And the next thing is that even though, for example, we have here our center mark, it is like one of, you can say, standards or rules when creating the 2D drawings is that we have center lines, which are lines that are showing different circles. Because, for example, if we see this could be a circle, a hole, or it could be even like it might have like a square cross section and then it's cut into the part. And so those center lines simply tell us that in here we have a hole or a circle drilled into the part. And at the same time, this could also help us in giving dimensions. But normally, what's happening is that when we would like to give the position of a hole, we do it always in the orthogonal view. We don't do it in one of the side views. And the same thing applies for the dimension of the hole. For example, here, this is, we could give the dimension, and we can see here that it says through 0.31. The reason is that because we are giving the dimension in a view that is not perpendicular to how the hole. So if we see here in the orthogonal view, we can see that the hole is on the slanted or inclined surface. And so the shape that you are seeing here or the size you are seeing here is different since it's projected. So as we can see here, this is circular, but in this view, it is clearly shown as an ellipse, not a circle. And that's why you are seeing this. However, if, for example, we do the same thing for this hole, we can see that it gives the dimension directly of here 0.5 as the dimension. However, another command other than the smart dimension that could help us is that because a lot of the times there are different holes and holes are used a lot for like combining different like parts in an assembly, we have the possibility to simply create dimensions for holes. So if we go, for example, in here, we could use this hole call out to be able to dimension this as the counter bar. Like the smaller one is 0.5, and through all, the bigger one is 0.75 with a depth of 0.35. And with this, we have all what we need to create the similar drawing to what we have in here. However, in this case, I added this hole to be able to show you one of the new features. For example, this is not available here, but I added it so that I can show you one of the different auxiliary views. So here we have the main three views, the front, top, and right, and we have the other main orthogonal views of front, top, front, left, right, back, and bottom. However, sometimes those views are not enough to give all the information needed about the part. So as I said, if we would like to give the position of this hole, normally and most commonly in a lot of the standards is that you should give it in the orthogonal view. So what we could do with this, since it is an inclined surface, we could simply go orthogonal or perpendicular to that. So if we go to our part, what we could do is that instead of using, for example, one of the standard views like the top view, we could simply go to this surface and go to normal to it. And with this, we can see the circle with its true dimensions as being full circle instead of an ellipse if we go to any of the other views. So to do that in the drawings, we could simply go to the drawings tab. We have here our model view, which will simply create those views that we have, and the projected view, which will do similar to what we did when we took a view, put it, and then drag it. This is the projected views. And here we will see the auxiliary view, which simply creates a view that is perpendicular to whatever edge you selected. So we have our hole here, which is on this edge. We can see here its hidden features, how it's available here. So we could simply select this edge, left click, and we could have here the orthogonal view. So we are looking to this surface perpendicularly. And so we can see here how this circle is now hole is a fully circle instead of an ellipse, and it also has a center mark. Since in this view it is perpendicular, and we could here give the dimension of this to any, for example, of the vertices of the shape. This is one option to give the dimensions of the hole. And since here, for example, in this view, the only thing needed is that this hole, we could simply also hide the other parts. Like, for example, we have the option if, for example, we select one of the edges, we could simply hide it so that it's not visible, to be able to focus only on the parts that we are interested in. And so this is the auxiliary view. And here are like, most of the time, the only things will be used is smart dimension. And here we have also notes, which will sometimes be used to help in defining some of the features in the part that cannot be easily defined with the smart dimension. For example, if we would like to say, for example, define a material, we could say like material X. And with this, we'll simply create a note for reference, or we could simply create a note at the title block with the same thing. We could simply go down and note, which will help us in giving some information about the part for to reduce the clutter or like the amount of dimensions given to make the drawing easier to read. And from this, after finishing, we could simply save it. And when saving, as we have different options, we can save it as drawing, or we could save it also as a PDF, which is what I did here so that we can find our drawings. Another thing is that we will see later in the other parts is that with those dimensions, you could modify them as you want, but most of the time, the defaults are good enough for us to give all the dimensions or information we need. So going from this part, we could simply close it, don't save. We could go to our part where we used the revolve and the circular pattern commands. We could do the same thing for this part as well. File, make a drawing from part, and we could choose a template. Here, A4 and C. The same thing we have here, but this time, since we know our part has circular symmetry, and let's say if we would like to recreate this, we could define all the dimensions in only two views. Because if we check the views, for example, we have here the top. If we see the right and the top views, they are the same thing, and the top view will not give any extra information than what is given in the right view. So only two views are necessary for this part. And the less views you can have in for this, describing a part, the better, since it will reduce the amount of clutter and the dimensions in the drawing, which will make it easier for whoever is reading this part to be able to get that to be able to have all the information regarding this part. And so from here, we can see that in here, we have this cross section or section view, as we explained when we were creating our part, with this section view that shows how the part will look if we cut it. We could do the same thing here, since this will help us in defining the different features of the part. So first of all, we could have the hidden lines, or we could simply hide them, depending on whatever you would want. However, what we could do is that for the section view is we could go to the drawings, and from here we could go to the section view. And here we have various options. Here we have the section option and half section. For the section, we also have a different cutting lines. So if you would like to cut it vertically, we could simply go section view, this one, and select it. And then we could click OK to have our section view, as we can see here. And from here, we could, for example, to make it easier to read, those hatch lines, for example, we could change from material crosshatch to, for example, increasing the number of the hatches to be clearer with this part. Or we could have a horizontal cut similar to this, but at the same time, it will not give any information other as different than the vertical cut. And here we have other options, for example, for diagonal cuts, or for this part, if, for example, instead of having, like, let's say, an even number of holes like we have here, we have 12, as we can see here. If, for example, we have 5 holes, what we could do is that we could simply use this cut to create a specific cut where we cut along this line, and we just follow the line. So our view will be looking to the object or to the part from those views as we cut this part in the middle, which will also give us different information depending on the parts that we are creating. For this part, a simple section view is enough. And as a final option, we have here half sections, which simply does something between the right view and the section view. So if we choose this one, from here we have the section view, half section. We have different options that are described in the labels here. And we get something like this, where here the bottom half is similar to what we get in the right view, while the top half is similar to what we get in the section view. If we change this again as we did in the first one. And we could use these as the views that we would like to give our dimensions on. And with this, we could now continue our dimensions, giving the dimensions, for example, in here or in one of those views to recreate this part. Another thing is that, similar to what we did in our parts, when we're creating parts, we had sometimes geometries, circles, lines that are not like used to create the part, but they are used to help us to construct the different geometries of the part. And here we can do the same thing. So as we can see here, for example, we have this circle, dashed circle, that helps us in defining where those holes are, we could create this by simply going to the sketch, and from here we could choose the circle and sketch, for example, here our circle, and setting it to be for construction. And with this, we could dimension this so that we have our circle that will help us define where we would like to put our features. And with this, we can see how we can create the different parts or features when describing a part. Another thing is that's important is that, as I said before, we would like to reduce the amount of dimensions as much as possible. And so we can see here, for example, that we have 12 similar holes. So instead of simply trying to go to every circle and giving the dimensions of every circle, this will be tedious and it will not give a lot of information since all the circles have the same dimension. What we could do is simply something similar to this, where we simply say how much we have of that feature. And so we could go to smart dimension. Let's choose this one, for instance. And if we zoom out, we could have this one. And from here, we could double click on it. And from here, we could have the different dimension text. So whatever I write here becomes visible in the dimension. And so what we could do is here we know that we have 12 circles. So we could go to the beginning and write 12x so that we can specify that we have here 12 circles or 12 holes throughout this part. And the same thing can be done for the triangles in the middle, as we can see here. This could be useful to reduce the amount of information or like the dimensions on the sketch, but at the same time, we should be careful because by saying stating that you have 12, we need to make sure that all of them are like close enough for the person reading this sketch to assume that all of them are similar. If, for example, they are not similar or they look different, it's better to give the dimensions to the whole to make sure that no one misunderstands the different dimensions of the whole in our part. And so here we saw the different annotations we saw the sketches, and here we'll be continuing with the different drawing views. So if, for example, we stop from this one, we could now from here go, for example, to this part that I created just to show one of the views in here is that if we go to this part and make drawing from part, what we could do is that we could have here the part, for example, the front view and the top and the right view, which will be enough since the top view will not give any extra information. So we could stop in here. And as we can see here, our part is relatively small and we cannot give the different dimensions and features of this small extrusion or cut in this part. So to do that, if, for example, we have a complex part and we have a small detail, what we could do is that we could go to detail view. And what this allows us to do is that it allows us to draw a circle, and anything inside the circle will be zoomed so that we could give the different details. So with this, we could also change the scale of this one. For example, if we want it to be bigger so that we can give the different dimensions, we could have here, for example, 2:1 or 5:1 so that it's clear and we can give the different dimensions for the different features. Or, for example, in our case, a detail view might not be needed. The reason is that we can see that this is a very long part, for example, in tubes or bars, and a lot of this, the region of the part in the middle, it is not necessary and does not contain any information. The important thing for us in this part is its overall dimension. And so what we could do is use a broken view, a break view, which simply allows us to reduce this length of the bar to be smaller since the middle part has no information. So what we could do is that, for example, we can see here those zigzag lines. We could left click on one part and then on another region. And what happens is that this part gets removed in the middle, and those zigzag lines state that or explain that what we have here is that we have a broken view or a break view. And here, this is a simple continuous bar. And so with this, what we could do is simply we could go to the sheet and go to the sheet format, right click, we could go to properties, and from here, we could change the scale. So instead of 1 to 2, we could do it, for example, 3 to 1, apply changes. And with this, the part now is clearer, it's bigger, and a lot of the information in the middle regarding its length is unnecessary. And so we could simply remove it so that we could increase the scale of our part and so give the different dimensions for the different features. For example, the length of this one. Instead of, for example, using a detail view. Or again, if, for example, this is not an option, the break view, you could always use the section view or the detail view to zoom in the different features or different regions of your part. And the last view that we most of the time is used, but here this is mostly used in assemblies or like in like tutorials on how, for example, parts are built and not used a lot for manufacturing, is the breakout section. So if, for example, you go to our first part and again make drawing from part, okay, we could go, for example, to the front view, top and right. Okay, we could show the hidden lines, and with this broken out section, what this allows us is to draw a shape, any shape that we would like. And if we click on preview, what this does is that it slices our part inside this shape, and the deeper we get, as you can see here, we are somehow slicing the part to see the inner sections or inner regions of our part or our model. And with this, it simply gives us a better view of how the part looks from the inside. And as I said, this is not used much, but it's also an option if, for example, you have an application where you need to have this broken view. And with this, like we have all the different commands that are used in the drawings. And with this, you could define or create a 2D drawings for any part that you'd like. As a final note, since a lot of you might say like, why are we creating those 2D drawings, for example? Since we have our 3D model, we could simply, for example, in 3D printers, you could simply send the 3D model to the printer and print it. However, the thing is that when, for example, wanting to manufacture your part, for example, via other manufacturing technologies, CNC machining, casting, etc., what you will need to do is that you cannot get those dimensions as you would like in the drawings or in the model. There will always be like some error or tolerance. So for example, our part here might not be always 3.25 inches. It might be 3.24 or 26. And so what we could do with the 2D drawings is that when we give our dimension in here, for example, if we change to inches, this gives us the option to create a tolerance, which is an important part in GD and T, which is geometric dimensioning and tolerances. And so this are different options for the tolerance that we'd like to add. For example, if we add asymmetric, and here we could like 0.1, we can see that here what we are saying is that our dimension of this part is 3.25. It is what we would like to get, the ideal case. But anything, if for example it's plus 0.1 or minus 0.1 inches, then it is also acceptable. And so with this, what you could do is that you could define different tolerances for different features to help make this part as manufacturable as possible, in that the bigger the tolerance, the easier the part to be manufactured, since not a lot of details needs to be taken to create this dimension. And this is what you should aim for if, for example, you would like to put tolerances, since it will make the part cheaper to create. But a lot of like manufacturing technologies and manufacturing processes could have a very high accuracies. For example, you could have plus minus 0.1 or 0.02, for example. It is possible, but what this will do is that it will make it a lot harder to manufacture this part, since the tolerance or the range for the dimension is too low. And so this is one of the like things as engineers that we need to focus about when creating our 2D drawings to be manufactured in various factories, is that we need to have all the dimensions and features given, as well as tolerances that are acceptable, and the tolerance should be as high as possible so that the part will be as cheap as possible while at the same time being functional. And with this, we are done with like our class for today regarding the different options and tools that are available when we are creating our 2D drawings. If you have any questions, feel free to ask. If not, thank you for listening.